Hello students, your physics teacher Hassan Darwish with you. In this video, in fact video 5 of mechanical oscillations, I'm going to explain the compound pendulum, the oscillation of a compound pendulum or physical pendulum. Let's start. But first, what is a compound pendulum? Let's see this small video. Here it is. Okay. Now you see here a vertical beam or rod or bar oscillating around a horizontal axis. You see the axis here, you see only the pin of the axis, and the bar oscillates around the horizontal axis. But the compound pendulum not only necessarily be a bar, clear? It could be any physical object, could be a disc, triangle, any shape. Okay? So here it is. It is a body oscillating around a horizontal axis under the action of its weight only. Clear? Let's make the pen a little bit thicker. This is the body. Here is the pin of the axis passing through O, means delta is here, passes through this point. This is delta, axis of rotation. Okay? Let me draw it cleanly. This is the axis delta passing through this point. Okay? And G is the center of mass of this body, this rigid system. A is the distance from the axis delta to the center of mass. G0 is the equilibrium position. So here, so as I said in chapter 1, this is the equilibrium position of the center of mass. Clear? Okay, let's start. What is the objective of this exercise? Is to determine the aim is what? Determine the proper period of oscillation. Determine the proper period. Clear? T0. And the nature of motion. Of course, by applying the principle of conservation of mechanical energy. Let's start. So, I am going to choose here, okay, first let me write the mechanical energy of this system at any time. Mechanical energy at any time. You know that it is kinetic energy plus gravitational potential energy. Now, kinetic energy at any time is half I theta prime squared. Don't forget this. Why? Because we have a rigid body in rotation. Plus M, let me write it capital letter, mgh. Now what is mgh? Here I've written plus because I'm going to choose the reference potential here in this level. Okay? At this level, let me use here. Okay. This is the reference level for gravitational potential energy. Okay? You could have chosen it passing through O, no problem. So we have in this case, this is H. Here is H. You see G? So this is H. And be careful, we are only interested in H. Clear? Let's make projection. So this is, let me call this capital letter H. So we get H equal H equal G0, right? Which is equal to O G0 minus OH. Is that true? But OG0 is A, the position of the center of mass of the body. And OH is A cosine theta if you use the right angled triangle. What is I? I represent the moment of inertia of the whole system, the whole rigid body here. And what is M? The total mass of the body. Clear? So we get half I theta prime squared plus mGA into 1 minus cosine theta. Okay, that's the mechanical energy at any time. Since we neglected all types of friction, since we neglected all types of friction, what can we say? The mechanical energy is what? Mechanical energy of the system is conserved, right? So mechanical energy is conserved. This means what? Mechanical energy equal constant, right? Equal because it is conserved. So what's the derivative of constant? Is equal to what? Here we take always the derivative with respect to time. Clear? Of the mechanical energy equal to 0. So let's make the derivative. Then half I, what's the derivative of theta prime? 2 theta prime, theta double prime, plus mGA. Okay, let's make the derivative of 1 minus cosine theta here. What's the derivative of 1? 0, right? What is the derivative of cosine u in mathematics? It is minus sine u times u prime, right? So let's replace it here. So derivative of 1, 0, minus. What's the derivative of cosine theta? Minus sine theta times theta prime. This is a mathematical rule. Okay, we are equal to 0. Here it is, equal to 0. So rearrange this equation in an elegant form. And remember that theta prime different from 0, we get theta double prime plus mGA over I. All of these are constant. Sine theta equal to 0 with theta prime different from 0 in general. Okay? So what is this? We have the function theta and we have the function theta, its second derivative, theta double prime. But an important question here, important question. Is the motion of this pendulum simple harmonic motion? Is it simple harmonic motion? Yes or no? No. Why is this? Why? Since the differential equation is not of the form y double prime plus omega 0 squared y equal to 0. Though we have theta double prime here, right? But here we have sine theta, not theta. Be careful about this. So no. Why? Since the second order differential equation is not of the form, is not of the form y double prime plus omega 0 squared y equal to 0. Okay? So what do we do in this case? What do we do to make this oscillatory motion simple harmonic motion and consequently determine its proper period? We confine the oscillation to small angle, small amplitude. If we have small amplitude oscillation, what does this mean? What does that is? That is the maximum value of angle must be less than or equal to 10 degrees. Clear? So if you try this on your calculator, take sine 10 degree and see how much, and change angle 10 degree into radian. You can notice that sine theta approximately equal to the angle theta but in radian. Ask your mathematics teacher or physics teacher about this. Clear? So replace here in this equation sine theta by theta. So what do we get? We get this. Theta double prime plus mga over I theta equal to 0. Now we have equation of the form. Sorry. So of the form y double prime plus omega 0 squared y equal to 0. Clear? Whose solution is theta equal theta, as you know, cosine or sine doesn't matter, omega 0 t plus 5. So we have simple harmonic motion. Clear? Where, don't forget, angular frequency, where the angular frequency omega 0 squared, angular frequency omega 0 here. Omega 0 squared is equal to mga if you compare over I. If you compare, clear? You compare this equation here with this. Y represent here theta. Y double prime represent theta double prime. So omega 0 squared is mga over I. Clear? Implies omega 0 is equal mga over I, and consequently the proper period t0 equal to pi over omega 0 equal to pi radical I over mga. Clear?